Hi everyone and welcome back to my class. I enjoyed reading the autobiographies that have been submitted and I look forward to getting to know you even more each day. In our next lesson, we're going to refresh our memories on exponents and powers. We talked a little bit about expressions and we talked about simplifying using order of operations and evaluating. And then part of that process included powers. So our objective today is to evaluate expressions containing exponents. But before we do, I want you to take a moment and in your notebook, describe in your own words what a power is and give an example. In our live session today, we'll have a Zoom class later today, I believe it's during period 5, we will share some of those responses. Now let's talk about reading and writing powers. When I read a power, we know that that larger number is the base, and the smaller number, the subscript there, is an exponent. The first is read 7 to the first power. The second, 9 to the second power. It has a special name, and we call it 9 squared. We've got the third one there, which is 5 to the third power. This also has a special name. It can be called 5 cubed. And then we have 3 to the fourth power. We can take powers and we can write them in different forms. These are the exponential forms that you see on this slide. So now I'm going to go from expanded form into exponential form. Expanded form, you see that this first one, it's a variable, it's a factor and it's repeated. And we want to see just how many times it's repeated, which will tell me what the exponent is. X is the base, and there are 4 of them, so x to the fourth power is your exponential form. Now I have 2 different terms here. I have 2's and I have y's. I have 2 to the third power times y squared. I don't need a dot in between, but occasionally you might see 2 to the third times y squared. I technically would want to eliminate that symbol and write it like that. The third one has 3 terms. There's 3's, there's x's and y's, so I've got 3 cubed times x times y squared. The next one, 2 squared times 3 cubed. The last one, 1, 2, 3, 4, x to the fourth, and y squared. So we can take something in expanded form and condense it into this power form, base exponent. So powers, I've been using these words, let's look at them one more time. The larger number is the base, which is the factor, and the exponent is the small raised number that tells you how many times to multiply that factor times itself. So 3 to the fourth power in exponential form is, again, 3 to the fourth. Expanded form, 3 times 3 times 3 times 3. And then if you're asked to evaluate it, you're putting it in what we call standard form. 3 times 3 is 9, times 3, 27, times 3 is 81. Let's evaluate or simplify these next few problems. Go ahead and try them, pause the video, and check back with me to see how you did. Let's see, time to check. In this first one, I'm going to expand it to 4 times 4 times 4. Well, 4 times 4 is 16, and 16 times 4 is 64. I'm writing both the expanded as well as the standard form. 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Times 2 is 32. And I have 64 once again. The next one is 12 squared. Well, 12 squared just says take 12 and multiply it by itself. And that gives me 144. Any number to the power of 1 is the number itself. Now, when we go into a chapter on properties of powers, I take time to show you exactly how you go from the positive exponents to zero exponent to negatives, but I'll save that for that chapter. Now, when the base is 10, there's a shortcut. This just tells me that there'll be 5 zeros in my product. Okay, because when I look at this, it really is a product of multiplying this base times itself. That only works with the base 10. This one I can expand it, but I cannot simplify it any further unless I ask you to evaluate when x was equal to 2 or 3. So I can expand this, but I cannot simplify it until I'm able to give you a value. 5 to the 0 power. Any non-zero number to the power of 0 equals 1. I'll ask that question a lot throughout the year so you don't forget. Now the last one here says 4 times x times x. Now the reason why I threw this one in was simply because I wanted you to be aware that this is 4 times x squared. It's not 4 times x squared. We're going to do a problem in a moment, so I'm sort of giving a little preview of what's to come. Let's do a little evaluating now. Given a equals 1 and b equals 2, go ahead and substitute and simplify. Remember, evaluate says to take out the variables and replace it with given numbers. Simplify says perform all the operations, do the math. Well, if a is 1 and b is 2, and I'm going to square it, order of operations comes into play here. It gives me 3 squared, which is 3 times 3, which is 9. In this one, I want to square 1, and I want to square 2. Well, 1 times 1 is 1, and 2 squared is 4. Order of operations, left to right rule, and there I am. Okay. Knowing when we need to perform what's in parentheses first. So everything as you see in math builds, we talked a little bit about simplifying using order of operations. We talked about evaluating. We're putting them into the next step with powers. Here's what I was sort of hinting at earlier. I'm giving you two problems that look very close to being the same, but they're not. In this first one, I have 2 times 4 to the third power. In this one, I have 2 times 4 raised to the third power. So in this one, I could perform my powers first. That's going to give me 64 times 2, which is 128. I'm going to get 2 times 4, which is 8, and 8 times 3, we're going to see, is 512. Which is just 8 times 8 times 8. This is why I brought this up. This has to be evaluated as 2 times x cubed. This one says let's multiply first, then raise it to a power. This is one that gets confused very easily, so that's why I highlight this type of problem. Try these two on your own and check back with the answers. When you're done, look and see the answers that I have and see if we agree. So now we have a problem where we're going to look at multiplying something by itself once again. And as we're doing that, we're going to see that we have to just multiply 21 times 21, which is 441. Okay, we subtracted, and then we raised it to the power. So it's time for you to practice. You'll go back to the Canvas module today. You'll find our assignment, complete it and submit it on Canvas, and have a great day. Once again, we'll have a Zoom lesson today, so if you preview this first, great. If not, we go through it together later. Until then, have a good day.